Whenever you're ready. Okay. Okay, let's get started. Welcome to our weekly weather discussion. We have a special guest here today, a recently retired but long laboring former director of the National Weather Service, Dr. Louis Uccellini, who had all three of his degrees here at Wisconsin, and Louis's been the most loyal friend this department I think has ever had in its history. And so Louis, welcome. We're really glad to have you. If memory serves, and if it serves as any guide for, or history serves as any guide for the present, Louis will not remain silent during this discussion. But it's always fun to have him in here because we get into some really good imbroglios. And those of you who are undergrad, professional master students, if you haven't met him, we're going to try and keep this discussion a little shorter than normal just so you get a moment or two to say hello. You don't want to pass that chance up. So let's start today with our visible satellite movie. This is over the last, I guess it's like 6 hours, right, Pete? Yeah, last 6 hours. Yes. And there's so many beautiful things on this image. You could spend more time than we have talking about them. Let me just point out a couple of the bigger features for my own interest. One, here's a massive cloud head in a still developing system that's been affecting southern New England, and with a whole bunch of different meteorological elements there this morning. I think they're going to end up with maybe 8 or so, maybe more than that, snow in Boston. Freezing rain further south mixed with snow, so it's going to be a mess in the Boston to Washington, D.C. corridor. It's freezing rain in northern New Jersey earlier, but it looks like now it's probably cleared up. So we'll try and see what happens with this cyclone as it moves offshore. It's kind of the same event, although in a different stage of its development than what came through us last night and gave us, well, I looked at the climatology for yesterday, 1.8 at the airport, but that may have changed because of stuff happening after midnight. Up to that point, sorry? 2.7. 2.7, so a little bit more than that. That means we're at about 21.6 inches of total snow for the whole winter, which is barely more than half of what we usually have by the end of February, which is 40.5.
You want me to go to Ed's page?
No, it's okay. I've got them in my head. I feel like Bob today a little bit. Out of the last 138 years of seasonal snowfall measurements at Madison, including downtown and various other locations, this could be the 9th least snowy winter of those 138, and it may even crack the top 5 of least snowy. We're not done yet. So 1901 was the worst. I think it was less than 5 inches of snow for the whole season. So thank God I wasn't here then. I couldn't have stood that. But there have been 9 that have been under 20, or 5 that have been under 20 inches for the whole season. So
John, an interesting question about with the snowfall is, yeah, for some people, 21 inches is enough.
Right.
I don't know who those people are, but
me either.
Yeah. But the question is, how important is this snow this time of year in terms of getting things ready for agricultural interest when we get to spring? Because they could be hurting if we stay.
Yeah, I think the hurt may have already been imposed. I mean, we haven't had a deep snow cover all winter long. We had a couple of 3-inch snowfalls. We haven't had a 5-inch snowfall, and that hasn't happened in 3 winters. So this is a long time waiting for that. I think soil moisture is depleted when you don't have a deep snow cover. I don't know about late winter snow. I think probably beneficial for that reason. You at least save what's left as the sun comes higher and maybe the vapor pressure deficit gets higher and it's easier to suck it out of the ground. But I think any bit of snow we can get in March is probably beneficial. But I don't know that. It's not scholarly. I'm just making a guess on that.
Going on to that question, and it's kind of, I guess, out the wheelhouse of this discussion, but I'd be curious also if it's been cold enough for different diseases that if you don't get a cold enough winter for a long enough time, you can get more seasonal diseases to grow earlier.
Yeah, I don't know about that. There's probably temperature dependence on a lot of that stuff, isn't there? Yeah. It's been about 2 degrees below normal for February. We were about normal in January. So it's been an average cold winter. But never desperately cold. We only had the one day with -17. That was the first day of classes, and so that's it, or -18.
I guess one of the key things this year is how deep is the frost. And
yeah.
I think the frost is probably pretty deep, and this is probably a good year to kill Japanese beetles and a lot of the pesky insects, because there's not very much snow cover. Frost is going very deep.
Yeah.
Also, we like to see some pretty cold temperatures to kill the beetles in the trees. They're killing the trees, and it hasn't been cold like that. We haven't had any extreme cold. But I did notice just now in Colorado, in their mountains, they've been getting -20
Oh, is that right?
Just the mountains west of Denver. And they haven't done that for years.
So that's good to kill these pine beetles.
That'll kill a lot of the beetles that
Yeah.
are wiping out the trees that are
Yeah.
causing the fires.
Yeah, well, that's good news, that's good.
I brought it up anyways, just while you guys were talking. That's the
Oh,
daily
yeah.
temperatures. There's the rain.
For accumulated precipitation. So yeah, well, you can see we're about halfway
Yeah.
between where we are normal and same with the snow, of course,
Yeah.
with all the precipitation's falling, this frozen snow. So, and only a couple of events, that's we never had a 6-inch snowfall. I guess
It's gotta
there's
be
two,
a
there's an
couple days,
inflection
yeah.
point, yeah, there's an inflection point, yeah. So we never had that. But we're way below normal, and even with the Weather Service snowboard that they use out there, which always seems to pump up the totals, in my opinion. It's more than I shovel, almost every time, but anyway. But more features on this map. Look at this rope cloud all the way from southwest Georgia. It's continuous from southwest Georgia almost to the Texas coast. Really beautiful. Imagine seeing that. I'd like to be on the front edge of that. I've never seen one of those approach like that. But they happen quite often down in the Gulf of Mexico. I'd kind of like to see this. There's other ropey elements here along the Gulf Stream as well. But they're not as connected, obviously, to a frontal structure as I think this one might be.
There's like some wavy stuff going on just behind the leading edge too.
Yeah, yeah. On western 2/3 of the country, pretty much clear, as you can see. Very little cloudiness, a little stream coming from the subtropical eastern Pacific up through New Mexico, northern Mexico itself, and into Texas. But this is all clear sky, beautiful day on the west coast, beautiful day over the Great Lakes states, although a little bit cold for some of our visitors, as we've already heard. That's too bad. In fact, Louis might be in my crowd for brutally cold when it gets to be about 0 degrees Fahrenheit. I think that he probably would be. They gave me no end of grief over the last 2 weeks when I used that adverb a couple of weeks ago, and Greg says, what happened to you? It used to be Sergeant Rock when it comes to the cold, and now 0 degrees is brutally cold.
It's called age.
I think it is old age. So shore parallel band, and we'll see in the reflectivity some of that was snowing today. So this has been a really nice winter for lake effect snow bands and their geometry this year over Lake Michigan. So no exception today. Okay, can we take a look at the radar summary, Pete? We can't tell if we're having
There's
Ukrainian-induced internet issues or not.
It'll come up. It's just the name lookups are a little slow.
Okay, so here's our radar reflectivity across the continental United States and some adjacent waters. Light precipitation, a little occasionally convective, perhaps off the middle Atlantic, stretching all the way back towards southwestern Louisiana. That's along or just maybe ahead of the cold front associated with this developing system in the northeastern United States. It's interesting to see over southern New England, you can see the speckles of yellow and occasionally orange are confined to the southern locations where it's either snowflakes covered with a little bit of water or maybe even raindrops themselves. Not so in the Boston area and northward, and certainly not so over the Tug Hill and in parts of Maine and New Brunswick where it's almost all guaranteed to be falling as snow. I don't know anything about totals. We'll take a look in a minute about intensities from the surface map. And then some lake effect snows in the cold air back behind the cyclone. Although I think that the flow is more or less westerly, not so much northwesterly in a lot of these locations. This wave is still trying to become a wave. It's more like a shear line. It was over us last night. And it'll develop a little bit further as it moves eastward. So we don't get great fetch like we sometimes do behind cyclones. But you can see, even in this far out, zoomed out mosaic, just south of the peninsula, you see some nice shore parallel bands making their way southward. And then the same is true over, Gary. So there's intermittent snow showers in Gary and just to the east of Chicago. And that's about it, though, for active reflectivity across much of the continental United States today.
Do you think this gap is real, or is that just radar not seeing
That looks really fake to me. Doesn't it look like there's something that's wrong? Yeah,
I was looking on the other side, though. I can't really tell.
I don't know. It didn't seem like a gap in the clouds or cloud heights or anything that we saw, but it does look a little bit fake to me with those two, that sort of whole sector is zoomed out or something. Let's take a look at the surface map, though, to confirm where it's snowing and what intensities and all that before we start looking at upper levels. And we'll go to the west coast, too. We're going to make sure we do that. Okay, let's start New England, Pete. Okay, so we've got light snow at Boston, look at that, 33 over 32, that's miserable. That's gonna be like shoveling concrete when it finally stops. 35 at Provincetown, over 33, light rain. It's warmer at the Vineyard, light rain, same at Providence. And then it's snowing in north of Hartford, and it's snowing everywhere else in New England. Oh, heavy snow at, where is that? It's not Burlington, I forget. And light snow in Manchester. Light snow most places, it gets a little bit heavier up in central and northeastern Maine, same at Halifax, moderate snow. So, pretty decent event.
Moderate snow at Albany too. They've been getting heavy.
Oh, yeah, moderate at Albany,
They've been
yeah.
getting moderate, heavy snow all morning.
And then heavy at that Ithaca or Syracuse.
It's no, it's a little bit north of Watertown, so.
And that's a northerly flow, so that's not really a lake effect thing, probably.
That's that part of that leaf.
Yeah. So widespread decent snows for late February. It's not uncommon to get really big snows. I think, in fact, in 1645, there was a snow in Boston on the 26th of February that closed the roads for 3 weeks. They didn't have any snow was on the ground till the end of March. That's from Governor Winthrop's diary from that year. So that was a bad year for snow. And then the famous Great Snow of 1717 started on the 27th of February, 1717. It was 4 straight storms in about 20 days that gave, 4 feet of snow up near Topsfield, which is near where I grew up. So we still heard about them when I was a kid, at least I did. Maybe I was listening to the right channels. But anyway, yeah, I heard about those events. So let's see over us, Pete, in our region. Light snow, persistent over Madison. It's been a kind of an interesting morning. We've had these light snow showers with the sun pretty much out most of the morning. In fact, when we just got back in the building, it was snowing with the sun out. So, interesting. With a light northerly wind, low dew point, so the snow was really pristine flakes overnight, really nice. And then it was really much colder up over International Falls. It's not so bad now, 0 degrees, but it was, I think, minus 26 there this morning or something, and widespread minus 8 to minus 10 over the Mandan countries of Dakotas. So pretty intense. I'd say that's brutal, but maybe I'm wrong about that. Let's go further south, Pete. One thing that was really striking on the infrared, I show it in class every day, was how quickly the peninsula, southeast Georgia, and parts of South Carolina warmed up, because they were all prefrontal. So the front of the cyclone is somewhere in about like this location. 58 near Atlanta, 78 to the south, 59 in western North Carolina, 76 in central South Carolina. So you can see kind of where it is, northerly flow over the coast, Mobile down to New Orleans, 72 near Pensacola, so somewhere in like that. Look at these temperatures, 83 over 63. It's a tropical day down in Miami, Tampa, all these places. It won't stay that way because it's not that much farther away. It's quite a bit colder, 40 degrees colder in some instances. Look at that, Birmingham's 44, and well, they have those 83. So
John?
things are going to change there.
Look at the 65 and 60 up in Virginia, right east of the mountains.
Oh, yeah, yeah.
And that's what's been happening all year with these frontal systems. They're warming downslope of the mountains.
Yeah, and look at how dry that is too. There's a 32-degree dew point depression there. Yeah, so that's just pure adiabatic warming there. And it's a warm bubble because it's cooler on the coast, or not even on the coast. You don't even have to go to the coast. Yeah, that's really interesting. 81 over 64 in South Carolina. Oh, sorry.
No, I just wanted to say, the coldest place in Minnesota this morning was Seagull Lake, it was negative 42. Yesterday morning, it was negative 45. And actually, a lot of northern Minnesota is experiencing the top 5, top 10, top 20 coldest winters up till this point of all time.
Is that right?
And it depends on the location, but it's been very cold there.
Wow, I had no idea. I noticed on Wednesday and again today, Benji, the temperatures were the minus 20s near International Falls.
Yeah.
But I didn't know that there was like a string going there for the whole winter. Wow, that's amazing. So, in the old days, that must have been great for ice production because people make money on ice.
Yeah.
That must have just been a great year for them. Wow, doesn't matter now. Light snow again in St. Louis. Okay, I don't want to go over the whole map because we want to keep this relatively short. Let's take a look at some upper level Josh.
You want to go West Coast or?
Oh, yeah, West Coast satellite. There's not too much happening there, so I just wanted to point something out that I saw interesting on there. Benji, I didn't have to call on you for stations today, but what was the one you said, Seagull Lake?
Yeah.
Where is it? Where is that?
It's just west of Lake Superior on the Gunpoint Trail. It's probably like 45 miles southwest of Thunder Bay.
Oh, man.
So it's far northeastern corner.
You should be like a tour guide for Minnesota tourism. He knows every single station in the whole region, let alone Minnesota. Thanks. So here's the giant cyclonic circulation occupying the eastern Pacific today. I don't know how it looks on the upper level charts. We'll look at it in just a minute. But embedded within this big circulation, I'm going to count at least 4. 1, 2, 3, 4 mesoscale cyclones in the cold air. And cold because you can see the open cellular convection is pretty cold. I bet it's like minus 30 to minus 35 to 500, maybe even colder than that. But then the west coast and along the coast, absolutely no such convective clouding. It's one little patch here. But beautiful day over the western United States and western Canada. This is the main feature of interest in that part of the globe. And as I haven't seen the upper chart, I'm going to try and imagine what it looks like. I think it's probably going to be a fairly large upper wave, but embedded little vortex features that you might be able to identify in, say, the 500 millibar geopotential height lines. Although sometimes these things are organized just as a function of their convective nature. So I guarantee we'll see cold temperatures a lot, below minus 30 or minus 35. I don't know if we'll see any indications in the vorticity that can be implied from the geopotential height of those features at this early stage in their development. We'll see. So let's go to the 500 millibar map first, Pete, the super Pete.
The new GOES satellite's launching on Tuesday too, March 1st.
Oh, is that right?
Yep.
So here we are at 12Z this morning. So first let's look at our wave that just exited by about that time this morning. We were just seeing the sun begin to come out, and after about a 2-inch or so snowfall. Very intense horizontal temperature contrast here. It's minus 22 near Detroit, and it's minus 16 or so down here near Cincinnati, but it's minus 30 in northern Michigan. And I don't know if I'm drawing this maybe in minus 29 at Green Bay, maybe I'm drawing that minus 25 line right in like that, and my minus 30 right like that. So it's a pretty intense baroclinic zone, 120 or so knots on the southern side and only 35 on the north, so there's pretty intense cyclonic shear across this region and a decent little curvature maxima, though it is kind of spread out some. Michael was commenting, and he'll say some other things about this later on, that it wasn't obvious that various pieces of the Q vector were working in a way to produce, a strong thermal ridge, and I wonder if it isn't just the fluid strongly stretched here that has something to say about that. And the ridge development here is going to be minimal, I would imagine, for a while. Perhaps the cloud head off New England's going to build that a little more. And then here's another wave with desperately cold air. There's another advert. In southern, southwestern Wyoming, minus 37.5 is analyzed, but not observed. And very sharp shear line as well, and a pretty decent horizontal temperature contrast. Again, maybe the minus 20 line goes right up to, the northern part of New Mexico instead of well down to the south. Yeah.
I was curious, I know it's 6 hours later, but the placement of this upper trough and then the cloud head we saw in the satellite image over the northeastern part of the United States, there's a pretty good distance between those
Yeah,
two.
yeah.
I'm wondering, again, this might be zipping along relatively quickly, but that also would be a factor that wouldn't be conducive for significant development.
Yeah, that's true. And I don't think I'll show, I looked at it this morning. If you split the total QG vertical motion into the part forced by thermal wind advection, the shear vorticity, and the curvature, in this whole transect across the northeastern United States, those have equal contributions. In the next 24 to 48 hours, the contribution from the shear goes to 0, and it's all curvature. So this wave develops quite rapidly, but it hasn't yet. And it makes me wonder if we caught it, like you just said, 6 hours into more development might be the reason why you're seeing some of that cloud head expand. I don't know that that's not.
Early this morning, northern New York was getting creamed, 3 inches an hour.
Is that right?
Albany, due west of Albany up towards Lake Ontario. So it was really, so what, yeah, and it was moving. That's a really rapid, the background flow is basically, very strong.
Yeah, that's right.
It's southern Rockies all the way to Iceland, right? It's just.
That's very true.
But I was surprised how much snow they were getting. I was thinking,
Yeah, there's a decent widespread, baroclinic zone there. Definitely confluent flow with an axis just north of the border. And in addition to that, an upstream wave with curvature and shear vorticity, which is pretty strong here. And how many times is he 110 knots at Buffalo at 500 millibars? Not that often. So that's a pretty interesting scenario, although it's not the kind that would turn your head. It's not probably the kind that would make your book, right, on northeast snowstorms. You wouldn't look at this and say, oh, that's bound to be one of those cases.
Be a moderate event.
Yeah,
It's a moderate event.
but it's pretty intense when you think about all the little pieces. Very strong, look at this northwesterly flow, cold advection in the northwesterly flow. There's another vortex feature that tropopause depression is going to come out of the northern lakes in Canada. And then to get back to the west coast, it is kind of a broad trough, and it does look like there's one of the vortex features. I think that's the main one. You can see that one circulating around. There's a little bit of a hint of another one here. Perhaps, you know, and now I see them all, I guess, but I don't want to fake it. But that's cold, minus 38, and this is the minus 30 isotherm. So it is cold, broadly cold, and so there's some, you know, instability, probably free convection going on there, stretching columns. There might be some preferred places for that stretching to begin, but once it gets going, it'll take on a life of its own, most likely, because it's probably freely convective. Surface temperature is probably about plus 10, plus 12, so it's a, you know, a 7 or 8 degree lapse rate, and if it's saturated, that's free.
So, hey, John, one other point, I know I got this fixation on the East Coast, but the one thing we have not been able to lose in the month of February is the Southeast Ridge.
Yeah.
And even now, like you were commenting on how fast it warmed up out ahead of the front, you get heights like that, you can't get snow in the Mid-Atlantic. You can get freezing rain, you can get all that.
That's interesting,
But,
yeah.
you know, 588 heights poking up into, and then 590 in Florida.
Yeah.
It's just not conducive for.
That is a really good point. That just means you can't wrap your waves up at a southern
So
latitude. and make sure
January,
it's-
that got eroded, and, you know, troughs could, you know, could go to town, but February's just been like this.
Yeah, how interesting. And on the flip side, we're 2 degrees colder than normal. We've had a consistent northwesterly flow poleward of that boundary. It's really interesting. Ian?
I was gonna say that you can kind of see it in the right corner there, like a little signature of a cutoff. It's easier to see in the
Oh, right here?
tropopause. And this was important for me this week. I was forecasting for the Caribbean 600,
Yeah.
the outrace down in the Caribbean. And there's a huge cyclonic kink in the northeasterly trades associated with that cutoff.
Oh, yeah?
And so kind of an anomalous year. They're used to sailing in northeasterly with relatively good 15 to 20 knots, and it was a lot lighter and less than
Interesting.
normal.
So people are laboring to gain some edge in conditions that don't allow it, really.
And the interesting part, the northeasterly trades, you know, they run into that anomaly. They have to slide up the isotropic surface. The whole front edge of it categorized by nasty squalls. Really.
Yeah. I think I saw that on satellite this morning. There's an organized looking structure down in that region. Yeah, I like that. Okay. I didn't pay any attention to it, not knowing that. Okay, so some more cold shocks are in the offing, it strikes me, that this is going to just develop more of a wave-like structure. The question is, just where will it be intercepted in latitude? And it does look like in the forecast it moves just past us to the north on Sunday night into Monday. So another desperate cold shock is not in the offing for us, but it is for parts of southern Ontario and the arrowhead of Minnesota, it looks like. Can we go to 300 millibars, Pete? So we have a strong jet off the Atlantic coast, 170 knots, and then we're down to about 119 to the south, but this is the one that has the connection probably to that cloud plume that came across northern Mexico into Texas. So that's clearly a subtropical jet. Here's a nice polar jet right when we saw that fairly intense 500 millibar cold advection. So that's going to be a more important feature as the weekend goes on. And then here is the southern periphery of that broad cyclonic circulation. And that is a pretty intense jet. That's probably 150, I think, is that next contour.
What's the wind speed over Albany? I can't read it from here.
That is 115. Yeah, 115 in Albany.
And then further, like in Pittsburgh or?
Pittsburgh's 130, so it gets stronger to the west. It's 130 down near Cincy, 90 to the south. This is only 115 or so at Portland, 80 at Halifax, 120 or so up near Caribou.
So that's, you know, the heavy snow is exactly in the lateral, you know, you got double jet.
Oh, yeah, that's
you got
right. Yeah,
Double jet,
right in this
and you
region.
got the exit region where the heavy snow is.
Yeah, that's right. That's a nice situation there. It'd be nice if we had time to put a cross-section right through there, and you might even see vertical motion plumes at different elevations in that location. Let's go to 200 while we're here, Pete, just see if we can make a discernment between these two features. Last week we couldn't, it wasn't easy to do that. It isn't this time either. This is a little weaker at 200, so maybe it's a conjoined polar and subtropical jet. This is a little stronger at 200, so this is obviously subtropical. But what they're doing in between, which is right where the heavy snow region is of great interest. It would be interesting to see. And you can even see curvature at 200 millibars just upstream of that region. So there's just about everything you could ask for is happening in the right place. Weaker jet at 200 millibars over the northern chain of lakes in Canada. So that's clearly a polar jet, an easy way to determine that. Sorry?
There's an interesting phenomenon going on right now. The polar night jet is ridging way up over the Alaska, Aleutians. And I think you're seeing, at 200 millibars, you're seeing some reflection of that ridging. But there's a huge gap between the polar night jet and some of the other jet stream activity to the north over the Pacific, and where the other jet streams are to the south, the subtropical jet in particular.
You mean a latitudinal gap?
A big latitudinal gap. And it looks to me like the polar night jet will keep ridging up. It's getting very close to the pole right now.
They're forecasting a wave 2 warming.
That's what I'm wondering. It looks like it's starting to approach the pole. If it flips over the pole, we kill the polar vortex.
Yep.
Is somebody forecasting that?
Yeah.
So that, yeah, that's what I see happening.
Yeah, so that's an early end to the winter.
Yeah, well, yeah, it
It's
changes it a
been
lot.
one of the coldest winters in the polar vortex on record.
Is that right?
Yep, so ozone loss, PSC formation.
Wow, how interesting.
But you want to go to my plot and see where I can show you how these jets are diverging apart.
There you go. I'm done anyway, so that was the last thing I was going to show.
It's just gonna take a second to load because the network is still being so weird.
Just get towards the,
That one?
yeah, that one, that's fine. Okay, so this is the polar night jet up here. Look at how it's ridging up, going up, and it's spreading out here because it's losing accuracy right near the pole. So it's ridging up near the pole and you're getting this big gap. What's causing it to ridge is the very strong energy coming off the tropics here, which is feeding into this and causing it to ridge up over there.
How do you know that, Greg? I mean, it doesn't show that.
Because they're coming together. This has got a lot of energy. Whenever they come together, you get, a lot of things start to happen in the polar night jet. And you can see down through the jet that these two are merged. If you cut a cross-section through that vertically, you'd see that the velocities are merged all the way from 25, 30 kilometers all the way down to about 10. So this is picking up this energy from the tropics, ridging that up. And over here, we're getting a breaking Rossby wave. So this is not making all the way across. This is breaking, so we're getting westerly jet at the equator. And here's what's causing the East Coast right now. Stop at the first one, Pete. This is for 8-day forecast from this morning. Yeah, so in the first one here, here's where the subtropical is merging into the polar night jet. They're different heights, but they do connect vertically when they get underneath each other or over the top. In New England right now, this is right at that merger point. That's where there's usually a lot of vertical motion and things going on over there. So what I see is this big gap. This is much more than we've seen recently between the subtropical jet and the polar night jet, as the polar night jet seems to be migrating over the pole.
Okay.
And that looks like it's going to change things fairly dramatically.
All right. Thanks.
Thanks, Greg.
Yeah.
And the first goes to the next, to their snowfall. So this is from the Weather Service office at Milwaukee. This shows the snowfall totals loosely from Thursday night, not really a time given on that, to Friday morning. We know we had some snow earlier yesterday morning and during the afternoon, which was light snow, which is lake effect snow with a strong easterly flow over us. But then, as we'll see in the radar loop that Pete has created, we had this wave of precipitation approach associated with a weather system that's now in the northeastern part of the United States. I thought it might be interesting to just briefly try to tease out what was going on with this. I thought this might be pretty straightforward, and then when I looked at the maps, I don't really get a good sense of it. But you can see enhancement from the lake with a heavier amounts along east along the western shores of Lake Michigan. And here in Madison, 2.7 inches of precipitation. Most of the snow fell in the southern half of our state, and again with the enhancement along the western shores of Lake Michigan. Pete, if you want to show that radar loop that you put together, it's about 24 hours long. Because it starts around yesterday morning, around 11 a.m. You can see the light lake effect snow that we had, and then we had this burst of precipitation beginning. This is going out to toward midnight, and then the system sort of exits with a persistent northerly flow of snow along the lake shore, and then moving into the center of the lake.
You don't often see vertical shear in the radar.
Right.
But it's
Here's
pretty
the
nice
radar,
today, yeah.
right.
180 degrees of shear.
But it wasn't the most impressive of systems, and I remember commenting to you, John, as we were leaving. You're leaving yesterday afternoon or evening. Wasn't expecting much. I mean, 2
Yeah,
inches,
yeah.
I thought would have been out of the question. I was expecting maybe half an inch to an inch, but Weather Service was going 2 to 3 inches, I think.
They were right on. I agreed with you, yeah. I didn't think so either.
So, if we go to the terminal,
And Belleville, which is in between Janesville and, they had 3 to 4 inches.
Is that right?
Yeah, it was,
It's a great call, and they made it. They nailed it.
so what I've set up is this is the 18Z run of the NAM, and these are actually every hour from 6Z to, not 6Z, excuse me, from 0Z through 12Z this morning. And what's going to be plotted are Q vectors, divergence of Q vectors, as well as potential temperature at 700 hectopascal. We can look at different levels. I was trying to just tease out from this, is there any sort of coherent structure that we could use to identify what's going on with the system? And the only thing I could see was there's certainly Q vector convergence, but the Q vectors were largely aligned along the isotropes, which indicate a rotation of the isotropes, and perhaps the attempt to create a thermal ridge, but it just was unsuccessful at happening. So if we first run this, I think if you semicolon L, it might already be loaded up. This is at 700 hectopascal. We can look at different levels. Sorry for the poor choice of colors. You can change that if you'd like. But we'll let it run through one more time, and we'll stop it at the beginning, which is at 6 hours before. You can stop it right there. We can go semicolon B a couple times to go backwards. Yes, this might be faster in Python, but.
Well, how do you do it in Python? You have to do something, B, probably, don't you?
Okay, 2 more. You do 2 more. We can do that. Yeah.
Billman's piping up about Python, Michael, and maybe you can't do it in Python.
Right. Impossible. So here is, this is 0Z last night. So that's when the snow was really beginning to set up over us. I mean, look at this, the Q vector convergence. Again, you have to look at multiple levels, look at all that. But this pattern isn't really one that strikes me as, oh, this is the most exciting event that I'm going to see. And obviously, I don't get that excited about snow. But here's the Q vector convergence over the southern part of the state, parts of eastern Iowa into northwestern Illinois. But you can see some curious features here. This is suggesting, and this is, if you look at different levels, you'll see a very similar pattern. Frontalysis, which is one thing. You would be running to say, oh, this is going to be an interesting event. And again, a significant along isotrope-directed Q vector distribution. Again, it's variations in the Q vectors and its convergence that's going to be seen as, quote, forcing for vertical motion for ascent or descent. And it's just a really weak pattern on the map here. If you go further to the southwest, it's a much different pattern that shows up there with significant Q vector divergence, and there's frontogenesis occurring in this region as well. It's all in the southern part of this. So if we step forward a couple steps, semicolon S, a couple times just to see a few other times, and we've got again sort of a broad thermal ridge, but it will animate it again. You don't really see much in the way of its changing structure as it animates, as you see the wave pass by. Here's this period, again, the snow, the vertical motion you'd expect to be fairly decent at this time as that Q vector convergence goes by. But again, this is frontalysis.
Yeah, interesting. But it does put the ascent on the cold side, which is what you needed, so
Yeah, so it's getting what you want, but it's just kind of
a weird way to get
a
there.
weird way to get it. And we had a couple more, and then again, you can see nice frontal circulation down in the southern part of this over parts of Oklahoma, where the ascent ahead of this developing front and the descent behind it was diagnosed by the vector divergence.
It is weird.
So we just have to have a couple more clicks, please. And just look at that. At this point. Okay, this is now close to 12 hours, it's midnight, just as the snow was ending. And the back edge of the precipitation at that time was just getting to the eastern part of our state. So kind of consistent, at least with this particular signal. And again, if you look at a couple different levels, multiple levels, a few tens of million, 50, 100 millibars above this or below, you see a very similar structure, so I think this is pretty consistent. But along the developing front, obviously a nice active band of warm and rising cold air sinking, a nice frontal circulation there, active frontal circulation in that region. So if you animate this with just a semicolon L, you can see the progression of this feature, even though you have a signal that would indicate that there is significant warm advection that wants to move these isotherms northward and amplify the wave, it never really gets accomplished.
Yeah.
This just moves along to the east, and it's not a particularly inspiring disturbance to look at, but on the other hand, it did produce a pretty decent, light to moderate amount of snow over this. For this winter, that's about what we saw.
So Pete,
Yeah.
I just brought up the 0Z initial state
Yeah.
in the GFS and then pushed 1Z just to the chance. And southern Wisconsin's right in between the two jets, like New York State was between it this morning.
So it's a very similar structure.
It's a very similar, it's a beautiful, coupling, lateral coupling of the jet stream.
So what we could possibly do is we stop this loop.
But what level would you?
This is at 700.
700. Well, the frontalis in the exit region, it makes sense, actually.
That's consistent with that.
Yeah.
With that sort of circulation. Right. If we could go to tropical tidbits, this is, and it's maybe a little bit slow, maybe we can just do a very quick cross-section through that.
So Ross Lazier says hi, he's watching online.
Hi, Ross.
He says, did Michael just say he doesn't get all that excited about snow? And Louis Uccellini is visiting?
All right, so if we go to zero, we'll go to the 0Z. Let's go up to,
This is 300.
Okay.
300, oh, that's
Always fine.
Yes, you hand this over the tropics, this is what you get.
Well, that's not gonna help. Sorry, Pete, go back here. Just want to see a jet.
250 millibar wind.
Where do you see that? Where do you see
Right
that?
there.
Oh, right there. And what would be a good point to do a cross-section, Louis?
Well,
Where do you want to start?
I would, at that point, what time are you at?
This is at 0Z.
You,
0Z, so,
No, that might be no. Is it?
Oh, it's 18
Oh, it is,
hours.
yeah.
Yeah, there we go, there we go, there we
there you
go.
go. So, right to the exit region.
Superior to Lexington, Kentucky.
Controller.
Yeah, from northeast Minnesota right down to West Virginia or
Click
something.
and drag or?
Right.
Well, maybe
I think it's
maybe a
control.
little
You
bit
gotta do
further
control.
southwest, yeah, right in there. Maybe a little bit further southwest, like that.
Oh, that's,
Yeah, right in there.
that's good,
Yeah.
yeah.
You want to get the long-term variation.
Let's, we could look at,
RH and Omega.
yeah, original Vegas into that. Of course, it doesn't show the isotext on those.
Yeah, you know what I say about that.
Get the upslope.
Yeah.
We got the upslope. At least on the first one.
Okay, we have this, I mean, this is going from A to B, north to south, and you can see this plume of moisture that's along this.
Yeah.
And you can see the frontal zone as well as you cut through it. But the heaviest precipitation, the biggest signature seems to be in the warm side of this.
Yeah, some distance
Go
along
to
the
the,
water.
please, yeah, let's do that.
And they don't use the same vertical scale on all of them either, unfortunately.
Right.
So that could be a problem.
So there's a nice jet core, nice triple pulse fold that extends down along that.
Yeah, and in the blue strip there, I think, in the PV, the low PV, that's where the updraft is. I think.
And that's about halfway, that's pretty close to us, so,
I wish you could overlay these, that'd be even better.
yeah.
I think that.
Right, so is it,
A vertical motion would be all along that front line, it doesn't have to max out on the left side of the jet.
right. Interesting
I
structure.
don't know.
So, and the point here, for folks that didn't quite get that, is the same time that was seen associated with the moderate heavy snow in the northeastern part of the United States was associated with these sort of, this departing jet and this approaching one, was over us last night. And so while we didn't see, we saw evidence for the Q vector convergence and the photolysis that was diagnosed from those Q vectors, a lot of what was going on was perhaps aloft with the looking at the front of the jet circulation at that level. Okay, thanks, Pete. And we'll just quickly go to sort of short-term weather for us. We got off to John's favorite meteorogram. Big news here is we get from desperately cold to just chilly over the weekend, with temperatures moderating significantly today, tomorrow, and on Sunday, maybe not quite as warm, but dry for the period. And kind of interesting, this pattern here with the dew points dropping off. But let's take a look at the time-night section. So it's the 6-hour forecast. Again, potential temperature is in yellow, starting from this morning at 12Z through 0Z on Monday, so Sunday evening. So you can see it's pretty quiet weather regime for us over the course of the weekend, with sort of brisk southwesterly flow starting tomorrow late tomorrow morning during the afternoon. So even though it's going to be warming up, it will be a little bit, it'll feel a little bit chilly with the strong winds. And then unfortunately we get a frontal passage again with some northwesterly winds when we get to Sunday afternoon. But in general, temperatures moderating significantly from today and yesterday.
It's interesting, you're getting those northerly winds at mid-levels, but the tropopause is rising.
Tropopause is rising. So you have this ridge building in the north. We'll see that.
Oh, yeah.
Yeah, we'll see this in just a moment. So let's click this, go off of this for a second.
You
Peter.
also got that globe of high PVs.
That
There's
comes
a
down.
filament that's moving through, it's just moving out.
Yeah, so you'll see this in a second. If we click this
Yeah,
loop,
there you go.
it might be better to step forward, unfortunately, but can't really do that on this, I guess. Let's go to 12 hours just to start this off. So here's the low vorticity, ventral vorticity, excuse me, it went through last night, it's going to the northeast this morning. This is at tonight, or this evening, late this afternoon at 0Z. We have this strip of high potential vorticity that's going to come through, and as Brad noted, you can see the slight depression of the tropopause in that time length section. But it's going to go by without much effect on us in terms of sensible weather. But I think the more interesting thing is this broad area, this ridge, or trough, if you will, of potential vorticity, but ridge in the geopotential height field, low PV over Eastern Pacific and Western Canada. That's going to be affected, and what we've seen a lot over the course of this season, and it's somewhat expected, is with this tropopause, beginning to recede in terms of the jet also moving much further to the north. We're going to see incursion of warmer air over us coming up over the next several days as this ridge begins to build in. So we're seeing the tropopause height go up once this trough passes by, and we're going to be in a regime of relatively fair weather over the next several days. Yes, Brad.
I'll note that the NASA WB-57 is going to fly to the corner of southeast Minnesota, southwest Minnesota, northwest Iowa at 0Z, and we'll be
Yep.
sampling that at 55,000 feet as part of a NOAA field.
What's the interest? What's the?
We're looking at upper troposphere, lower stratospheric aerosols.
So they're
And
gonna capture
sampling
that.
into that polar vortex filament that's going to lift off.
So that was your interest in that when you saw that timeline section?
We've been, Gerald Ocken and I have been forecasting that for a while. We've been forecasting.
Right. And so that feature's going to be around for a while. You'll see it as it
Yeah.
progresses to the southeast and kind of gets stretched a little bit. Let's go ahead 12 hours, please.
But you'll have in situ, met data right in the core of that.
Just to give you a heads up, Michael, it is getting close to
Okay, thanks. So this strip is gonna be around for a while, it's kind of stretching out. We might get an opportunity to fly it multiple times, I guess.
Last flight of the mission.
Oh, lost light vision, okay. So let's let this animate once more and we'll just see, or we can just step forward again, another 12 hours peak. And again, this broad ridge over the west coast. But again, from the last 2 weeks ago, we were talking about the pattern being changed a little bit. Louise talked about the persistence of the southeast ridge, but I think really if you look at the northeastern Pacific and the west coast of the United States, things are a bit more variable now. You're getting more weather systems breaking through, producing some precipitation along the west coast. I think that's a good thing for where they need the rain.
I have a little bit of a worry that this polar vortex may sit over northeastern North America. And, it's gonna move off the pole.
Right.
Up here. But a lot of times it sits up there over Hudson Bay or to the northeast of the Hudson Bay. And then we keep getting cold pulses all spring long, it makes it miserable.
Right. As we're trying to wrap this up, but just, you make that statement, but what's your reasoning behind
Well,
that?
you've seen it before, where we have that cold low sitting up over Hudson Bay to our north in the spring. And it just sits there for weeks, and it keeps us from having, experiencing the real warm weather that we can get.
Right, because if we have a trough there, we're gonna get an eastern flow.
How is that a problem?
Well, it's a problem, because we're ready for warm air now.
Okay, and if we go just to the last image here,
Maybe we can get a snowy March.
this is really slow, so I'm probably just bring, but again, we get this nice broad ridge that begins to form over us, and the forecast, at least into early to middle of next week, is for moderating temperatures. And in fact, by the time we get to next weekend, we could be looking at temperatures in the 50s, maybe even approaching 60 degrees. But we'll talk about that next week. Anyway, thanks, John, for a great
Thank you,
presentation. Greg and Louie and everyone who's made comments today. And have a nice week. Again, it's a quiet weather.
You know how we get the most miserable spring.
I know, you're right, I mean, it can be cloudy the whole month, 30.
Yeah.
That stinks.
It's cold enough.
Huh?
It's cold enough. I've had enough cold.
Yeah, great. Now I'm so, hey, great.
Least snowy winters in the last 150 years too, so I think we need to get some ground on that.
There we go.
Hey, great, great
How long is
job.
that forecast?
Great job.
It goes up to
Problem
192,
is that
so
when you get those
that's
ridges building up towards
at
the pole,
50 hectopascals.
you actually start
We
getting
can go higher,
more
I've got higher
unstable
stuff too.
flows because the whole critical race temperature that has
Yeah.
talked about really kicks in. So by 14 days, I was just noticing that it finally starts, eastern flow is back off.
Oh, yeah.
Cutoffs starting to develop. So you have the whole possibility of that to having the low just moving straight